Configure VLANs and trunking. This topology, 2960 switches, S1, S2, PCs, PCA, PCB, fast Ethernet 1 between switches, 6 on S1 to connect PCA, and 18 on S2 to connect PCB. Addressing table S1 and S2, 111, 112, PCA, 10.3, PCB, 10.4. On real lab, 2 switches, 2960, 2 PCs, console cables, Ethernet cables. Build the network, already done. Cable the network, done. Configure basic settings for each switch. So I will only configure device name to the switch and IP address listed in addressing table for VLAN 1. Any other configurations were made in another labs for security and for basic configurations. Okay, go to S1. Okay, the host name S1, enter, enable, configure, terminal, host name S1. Interface VLAN 1, interface VLAN 1, IP address 192.168.111, subnet mask 24. Now shut down. Okay, exit. S2. Enter, enable, configure, terminal, host name S2. VLAN 1, interface VLAN 1, IP address 192.168.112.24. Now shut down, exit. Configure PC hosts. Use the addressing table PCA 192.168.10.3, 24, 192.168.10.1. For default gateway and PCB, 192.168.10.4, 24 subnet mask 192.168.10.1. Now test connectivity. Verify that PC hosts can ping one another. Can PCA ping PCB? Okay, go to PCA, command prompt, ping IP address of PCB. IP address of PCB is 10.4. PCA 192.168.10.4. Success. Okay, yes, the answer yes. PCA can ping switch 1. Okay, ping 192.168.111. Okay, this the IP address of switch 1 is 111. Enter. Okay, request timeout. The answer here is no. PCB ping switch to, go to PCB, command prompt, ping IP address of PCB, IP address of switch to 112, 192.168.112, enter. Okay, request timeout. Okay, so can PCB ping switch to? No. Can S1 ping S2? Go to S1 and on privilege exit mode ping S2 192.168.112. Success, repeat. Okay, all success. Answer is yes. If you answered to no to any of the above questions, why were the pings unsuccessful? Pings were unsuccessful when trying to ping a device on a different subnet. For those pings to be successful, a default gateway must exist to route traffic from one subnet to another. Create VLANs and assign switch ports. Okay, create VLANs on switches. On S1. Okay, configure terminal on global configuration mode. VLAN 10. Name operations. VLAN 20. Name parking underscore lot. VLAN 99. Name management. VLAN 1000. Name native. And create same VLANs on S2. Go to S2. VLAN 10. Name operations. Case sensitive. VLAN 20. Name parking underscore lot. VLAN 99. Name management. VLAN 1000. Name native. And show VLAN brief to verify. On S1, show VLAN brief. Enter. 10, 20, 99, and 1000. Okay, this is the VLAN 1, the default, but 10, 20, 99, and 1000. S2, show VLAN brief. 10, 20, 99, and 1000. What is the default VLAN? The default VLAN is VLAN 1. Okay, VLAN number 1. What ports are assigned to the default VLAN? If VLAN 1 is the default VLAN, all ports are assigned by default to the default VLAN. Assign VLANs to the correct switch interfaces. Assign VLANs to the interfaces on S1. Assign PCA to the operation VLAN. This is PCA and is connected to Ethernet 6 on S1. So on S1, switch port mode access and operation VLAN. Operation VLAN is VLAN number 10. So that's why switch port access VLAN 10. Okay, on S1, configure terminal interface for Ethernet 6, switch port mode access, switch port access VLAN 10. Okay, move the switch IP address VLAN 99. Okay, go to interface VLAN 1, remove the IP address on interface VLAN 99. Set the IP address 111 for switch 1. Okay, interface VLAN 1, no IP address. Interface VLAN 99 IP address 192.168.1.11.255.255.255.0. Okay, this is the IP address of S1. And show VLAN brief and verify that the VLANs are assigned to the correct interfaces. Repeat show VLAN brief command, enter. Okay, VLAN 10, fast Ethernet 6 assigned to VLAN 10, operations VLAN. Show IP interface brief, show IP interface brief. Okay, VLAN 1 does not have IP address, but VLAN 99 uses the IP address. Okay, status is up, and protocol is down. Okay, this is expected. Don't worry about this. What is the status of VLAN 99? Explain. Okay, status up. The status of VLAN 99 is up and the protocol is down. Up because the VLAN exists in the database, but protocol down because the VLAN has not been assigned to an active port yet. Assign PCB to the operations VLAN on S2. Okay, this is PCB and is connected to fast Ethernet 18 on S2. Go to S2, configure terminal interface fast Ethernet 18. Enter. Switch port mode access. And operations VLAN is number 10. Operations is number 10. Switch port access space VLAN 10. Enter. Remove the IP address of VLAN 1 on S2. Okay. Interface VLAN 1, no IP address. Configure the IP address for VLAN 99 on S2 according to the addressing table. Okay, use 1112 IP address, but on VLAN 99. Interface VLAN 99. Okay, sorry, interface VLAN 99. Enter. IP address 192.168.1.12 space subnet mask 24. Show VLAN brief. Okay, and to go privilege exit mode, show VLAN brief. VLAN 10 and fast Ethernet 18. Fast Ethernet 18 was assigned to VLAN 10 operations. Is S1 able to ping S2? Explain. Okay, go to S1, click, ping to S2, 192.168.1.12, enter. Okay, ping fails. Okay, the answer here is no. The IP addresses for the switches now reside on VLAN 99. VLAN 99 traffic will not be sent over interface facetternet 1. Okay, this interface facetternet 1. Is PCA able to ping PCB? Click on PCA and command prompt ping PCB that is 10.4. Okay, ping fails. So the answer here is no. Interface facetternet 1 is not assigned to VLAN 10. So VLAN 10 traffic will not be sent over it. Okay, this is facetternet 1. Maintain VLAN port assignments and VLAN database. Assign a VLAN to multiple interfaces. On S1, assign interfaces 11 to 24 to VLAN 99. Okay, use these commands on S1. Configure terminal interface range and set the range facetternet 0, 11 to 24. Enter. Switch port mode access and switch port access VLAN 99. Enter. Exit. Okay, show VLAN brief and on privilege exit mode show VLAN brief. Okay, facetternet 6 on VLAN 10 and from 11 to 24 on VLAN 99. Reassign facetternet 11 and 21 to VLAN 10. Okay, configure terminal interface range facetternet 11, facetternet 21. Enter. Switch port mode access VLAN 10. Okay, and okay to VLAN 10. VLAN 10. Verify. Show VLAN brief. Okay, 6, 11, and 21 on VLAN 10. Remove VLAN assignment from an interface. Use the no switch port access VLAN command to remove the VLAN 99 assignment to 24. Okay, interface 24, configure terminal interface facetternet 24, no switch port access VLAN. Enter. And verify. Show VLAN brief. Now 24 is not assigned to VLAN 99. 24 by default now is assigned to VLAN 1. Which VLAN is facetternet 24 now associated with? Okay, VLAN 1. Okay, VLAN 1, the default VLAN. Remove the VLAN ID from the VLAN database. Add VLAN 30 to interface 24 without issuing the global VLAN command. Okay, on S1, configure terminal interface facetternet 24. Okay, switch port access VLAN 30. Access VLAN does not exist. Creating VLAN 30. Current switch technology no longer requires that the VLAN command be issued to add a VLAN to the database. By assigning an unknown VLAN to a port, the VLAN will be created and added to the VLAN database. Verify that the new VLAN is displayed in the VLAN table. Okay, and show VLAN brief. Okay, this is VLAN theory. What is the default name of VLAN theory? VLAN 00 theory. Use the no VLAN theory command to remove VLAN theory from the VLAN database. Go to global configuration mode on S1. Configure terminal. In global configuration mode, no VLAN theory. Enter. And verify show VLAN brief. Okay, no VLAN theory. Okay, but remember, 24 interface was assigned to VLAN theory. Okay, interface 24 was assigned to VLAN theory. VLAN theory 24 assigned to VLAN theory. After remove VLAN theory with the no VLAN theory command, where is the interface 24? No interface 24 on VLAN table. After deleting VLAN theory from the VLAN database, what VLAN is port 24 assigned to? What happens to the traffic destined to the host attached to interface 24? When you delete a VLAN, any port assigned to that VLAN becomes inactive. So port 24 is still associated to VLAN theory. However, VLAN theory is now inactive because it does not exist in the VLAN database. Additionally, the port will not transfer any traffic. Issue the no switch port access VLAN on interface 24. Configure terminal interface FastEthernet 24. No switch port access VLAN. Enter. And verify with show VLAN brief. And show VLAN brief. Now 24 is assigned to VLAN 1. Okay, the default VLAN. To which VLAN is 24 assigned? Okay, the default VLAN, VLAN 1. Note, before removing a VLAN from the database, it is recommended that you reassign all the ports assigned to that VLAN. Why should you reassign a port to another VLAN before removing the VLAN from the VLAN database? The interfaces assigned to a VLAN that is removed from the VLAN database become inactive and are unavailable for use until they are reassigned to another VLAN. This can be a tricky thing to troubleshoot as truncate interfaces do not show up in the port list as well. Configure AO2.1Q trunk between the switches. Okay, disconnection. FastEthernet 1 in both switches. You will configure interface FastEthernet 1 to use dynamic trunking protocol (DTP) to allow it to negotiate the trunk mode. After this has been accomplished and verified, you will disable DTP on interface FastEthernet 1 and manually configure it as a trunk. Use DTP to initiate trunking of FastEthernet 1. The default DTP mode on a 2960 switch port is Dynamic Auto. This allows the interface to convert the length to a trunk if the neighboring interface is set to trunk or Dynamic Desirable mode. Fast Ethernet 1 on S1 to negotiate trunk mode. Okay, go to S1, configure terminal interface Fast Ethernet 1. Okay, this interface Fast Ethernet 1, switch port mode dynamic desirable. Enter mode dynamic desirable. Enter. Okay, you are changing from dynamic auto, that is the default configuration, to dynamic desirable. Okay, dynamic desirable. Okay, and look at this, VLAN 99 change state to up. Show VLAN brief on S1 and S2, and show VLAN brief. Fast Ethernet 1 is not longer assigned to VLAN 1. Okay, no Fast Ethernet 1 assigned to VLAN 1. Go to S2, enter, enable show VLAN brief. No Fast Ethernet 1 assigned to VLAN 1. Okay, no Fast Ethernet 1. Show interfaces trunk. Okay, go to S1, show interfaces trunk. Okay, and Fast Ethernet 1 is trunk. Mode desirable encapsulation, AO2.1Q, trunking, use native VLAN 1. And go to S2, show interfaces trunk. Okay, port Fast Ethernet 1 mode auto encapsulation AO2.1Q, trunking native VLAN 1. The difference is S1 was configured with desirable mode, and on S2 the default mode is auto. By default, all VLANs are allowed on a trunk. The switch port trunk command allows you to control what VLANs have access to the trunk. For this lab, keep the default settings, which allows all VLANs to traverse Fast Ethernet 1. Okay, for example, on R1, the VLANs allowed on trunk from 1 to 1005. Okay, S2, VLANs allowed on trunk from 1 to 1005. Verify that VLAN traffic is traveling over trunk interface Fast Ethernet 1. Can S1 ping S2? Okay, S1 ping S2 and use ping 192.168.1.12. Success. Repeat. Okay, all success. Can PCA ping PCB? PCA ping PCB. 10.4. Success. Very good. Okay, answer yes, answer yes. PCA ping has 1. PCA ping has 1. 1.11. Okay, ping fails. So the answer is no. Can PCB ping switch to? Okay, PCB ping to switch to 1.12. Okay, ping fails. If you answered no to any of above questions, explain below. The switches are in VLAN 99 and the PCs are in VLAN 10. Therefore, The pings between VLANs were unsuccessful. Also, you need a layer 3 device like a router or layer 3 switch to permit the routing between VLANs. Manually configure trunk interface facet node 1. The switch port mode trunk command is used to manually configure a port as a trunk. This command should be issued on both ends of the link. Okay, on facet node 1 on S1 and on facet node 1 on S2. On S1, configure terminal interface facet node 1 switch port mode trunk. Enter. Go to S2, configure terminal interface facet node 1 switch port mode trunk. Enter. Show interfaces trunk. Okay, go to S1 and show interfaces trunk. Now, the mode is not desirable, it's on. Manually configure it. Okay, go to S2 and show interfaces trunk, mode on. Modify the trunk configuration on both switches by changing the native VLAN from VLAN 1 to VLAN 1000. Okay, remember on S1 the native VLAN by default is 1, and S2 the native VLAN by default is 1. Change to 1000. Go to S1, configure terminal facet node 1 interface facet node 1 switch port trunk space native VLAN 1000. And on S2, okay, native VLAN mismatch. Okay, configure terminal interface facet node 1 switch port trunk space native VLAN 1000. Okay, very good. Port consistency restored. And verify. Show interfaces trunk. S1, enter and show interfaces trunk. Now, native VLAN 1000. S2, and enter and show interfaces trunk. Native VLAN 1000. Why might you want to manually configure an interface to trunk mode instead of using DTP? Not all equipment uses DTP. Using the switch port mode trunk command ensures that the port will become a trunk no matter what type of equipment is connected to the other end of the link. Why might you want to change the native VLAN on a trunk? Using VLAN 1, the default VLAN as the native VLAN is a security risk. All the different control protocols that are exchanged between switches are exchanged via the native VLAN 1 Untitled, and that information could be exposed if default settings are used on ports that users connect to. Delete VLAN database. Determine if the VLAN database exists. Show flash. Okay, S1. Show flash column. Enter. Okay, look at this file, VLAN.dat. This file contains all the VLANs. Delete the VLAN database. Okay, this is the VLAN database, VLAN.dat. Okay, delete VLAN.dat. Enter. Confirm. Delete file name. Enter. Confirm. Enter. Show flash again. Okay, no VLAN database. Okay, but show VLAN brief. you still have the VLANs, okay, because these VLANs are placed in the RAM, okay. To erase the RAM, you need to reload the device. To initialize a switch back to its default settings, what other commands are needed? To get a switch back to its default settings, the erase startup config and reload commands need to be issued after the delete VLAN.dat command. Reflection. What is needed to allow host on VLAN 10 to communicate to host on VLAN 99? To allow inter-VLAN routing requires a layer 3 device. Is needed to route traffic between VLANs. What are some primary benefits that an organization can receive through effective use of VLANs? VLANs benefits include better security, cost savings, efficient use of bandwidth and uplinks, higher performance, smaller broadcast domains, broadcast storm mitigation, improved IT staff efficiency, simpler project and application management. Thank you very much.